First thing I'll do is put the forces. I'll use this diagram here. Start off with this, the weight going straight down, 1.5 G, and there's the normal contact force, which is R. There's a weight on this one here, which is 1.2 G. I've got tension in the rope or string, so that's T. And it's a smooth pulley, so it's an equal and opposite for tension here. And also, because it says it's a rough plane, so I'm going to have friction going up here. And that's the first thing I need to do. Next thing, I always like dotting the line back here, putting in that angle, which in this case is 21 degrees, same as this angle. And it told me that the acceleration is A, so acceleration goes that way, and because it's an inextensible string, must be exactly the same acceleration here. And also it says that mu equals 0.8. So if I forgot the friction, mu equals 0.8 will give it to me. First thing I want to show that the frictional force acting on the block. The block is this bit here, and this is the object. It says it in the question, so it's worthwhile making sure you're really aware of that. So on the block has magnitude of that. So part I, what I'm going to do is it's moving, so I'm going to have limiting friction. Limiting equals mu times R. So I need to find out what R is, so that means I'm definitely going to have to resolve perpendicular to the slope. And that means my upward force is R is going to equal this force coming back here, and that bit there is 1.5 G times by cos 21. So R equals 1.5 G times by cos 21, and that equals 13.72363. That's not what I need to do. I want to find the frictional force. I know it's mu R, so F lim equals 0.8, which is mu, times by that 13.723, and that equals 10.9789, which equals 10.8, so 10.98 to 2 decimal places. Unusual, but that's what it says, 2 decimal places. Part 2, by applying Newton's second law to the block and the object. So that means I've got to do that. Or to the block, let's do it to the object first. Object resultant force equals mass times acceleration. I'm going to go in the direction of the acceleration, so I'm going to resolve downwards to get this. So that will give me 1.2 G minus T equals 1.2 times by A. If I want to write that out, that is 11.76 minus T equals 1.2 A. That's done the object. Now I've got to do the block. And block, I'm going to resolve in the direction of acceleration, so I'm going to resolve in that direction there, down the slope. Again, resultant force equals mass times acceleration. What's going down? Well, I've obviously got tension, but I've also got this bit here of the weight. And so I'm going to have the tension, let's put that first, tension plus 1.5 G times by that is sine, because it's opposite sine 21. Nothing else going down. I've got minus the friction, which I just worked out, minus 10.98. I should keep more accuracy really, 10.9789. And that equals the mass, which is 1.5 times by the acceleration. Gives me that. I can sort of link this together and it gives me T minus 5.71089 equals 1.5 A. And that's done me find a pair of simultaneous equations in T and A. So I've done that. I've now got to solve these. So if that's equation 1 and that's equation 2, nice thing about that, if I add these together, then then T will disappear. So equation 1 plus equation 2 will give me 11.76 minus 5.71089 equaling, and that will be, add them together, that will be 2.7A, and so A equals 2.240408, so acceleration equals 2.24 to 2 decimal places, and that does that part. And now I've got to work out part 4. Okay, we're now told that the object initially is 2 meters above the floor and the block is 2.8 meters. So what's going to happen is the block's going to go 2 meters along there, not to scale here, and then it's going to go another 0.8 meters along here. But by that stage, the object will have reached the floor, so the acceleration will change. So the first part, I've got to find find the speed of the block at the instant when the object reaches the floor. So when the object reaches the floor, I can just find out how fast the object's going. And so this will be a simple Stuva one. So equation is constant acceleration. S is going to go 2 meters. Don't care about time. Initially it's released from rest right at the beginning. I want to find the velocity, and the acceleration I just worked out is 2.240408. So I need the formula without a t in there, and that will be v squared equals u squared plus 2as. So v squared equals 0 plus 2 times 2.24 times by 2. So v squared equals 8.96. So v square root of that is 2.9933, or 2.9923 significant figures. And that's the first part done. And now to work out b, it's going to and that the speed is going the speed of the object, but since it's an inextensible string, it will be the speed of the block as well. Just check when I've done that, I have taken everything to be positive down here. So the distance is 2, the acceleration is 2.24. I really should have put that arrow in there just to remind myself not to make that mistake. I do know now that the block has hit the ground, and so now I'm not going to have the tension. The tension will disappear, so I need to find the acceleration for this last 0.8 meters. So that's what I'm going to do. First, find acceleration, and that means I'm going to have to resolve down the slope again, and resultant force equals mass times acceleration, and I've now got 1.5 g sine 21 minus the friction, which I worked out before, 10.98, and that equals the mass, which is 1.5 times acceleration. If I work that out, that gives me the acceleration is minus 3.80726. Now I can work out the final bit. I've got simple acceleration, constant acceleration, so Stuva. I now know my acceleration is minus 3.80726. The S is now 0.8 meters because it's only got to go that last part of the journey with the deceleration. T I really don't care about. U is what it started off to be, 2.9933, and the final velocity is what we want. So I need to have v squared equals u squared plus 2as. So v squared equals 8.96 minus 7.6145 times by 0.8, and that equals 2.8684. So v equals square root of that, which is 1.6936 meters per second, or 1.69 meters per second, 3 significant figures. And that's question 7 and the whole paper done.